is to talk about standardization of data. It's usually very important in data analysis and things like this because it transforms the data to a type of range which prevents from one data to be big or more influential because it has larger, I don't know, ranges compared to another one. It's normalizing the data, it's standardizing the data such that each group will have the same range, uh, not range, the same distribution. So one group won't be bigger or stronger than the other just because the units that are used in one group are are different from the other. Like if I'm doing distance between groups and one groups is calculated using, I don't know, centimeters for distance, and I just evaluate the value. So once 100 centimeters 1 meter. So in one group I will have 100 centimeter between two values, and in the other I will have the same distance, but this will be with meters, so it will already will be only 1 meter. And if I'm not counting the units, I will think that the other group, maybe those with the centimeters, maybe have the bigger amount of distance between the values, or think like this. So when I start analyzing the data, I make it such that everything will be in the same with the same distribution, uh, with the same mean, each group with the same mean, with the same standard deviation, and it will have better comparison abilities between groups. So I have a data. Here is the data, name and age. I have names and ages, and I want to convert it to standardize the data such that the age mean of the group will be 0 and the standard deviation will be 1. This is in standardization, or z value. uh, Okay, yes. So what I want to do that the standard value, the each age of the person there uh, will be like this. I will take each person's age, reduce it from the mean of the group, and divide it by the standard deviation. This is how the group will have a mean of 0 and standard deviation of 1, and it will convert to this. This is the original data, and this is after standardization. You can see that if you calculate after standardization, the mean will be 0 and the standard deviation will be 1. And this I can say that this value of David is 1.36 from the mean. And if I will look at another group now, again, and then I will standardize the other group, and I will have someone with, I don't know, value of 2, I'll know that he is more distance from the mean of the group compared to David because I'm using standardized data. So I can compare between two different groups. Okay, so I want to convert the data to standardized. What I do, I need the mean of the data, and for each value, I will again take the value and standardize it by taking the original value, reduce from the original value of each element in the group, the mean of the group, and divide it by standard deviation, and this is how I will standardize all the data. So I need to calculate the mean of the group and the standard deviation of the group, and the mean of the group is calculated like this: sum of age divided by the number of individuals. So I sum the age and divided by the number of individuals, and here it is, and this is the value. So I got the mean. Now standard deviation, this is the formula for the variance, and standard deviation is uh, the square root of the variance. Sorry, the standard deviation is the square root of the variance. So if I calculate the variance, I will be able to calculate the standard deviation. So variance, it's the sum of each element minus the mean of the group to the power of 2, sum all of this divided by the number of elements in the group. So here it is. I take each element and reduce the value of the element, the mean from the value of the element, take the to the power of 2, square it, and sum it all, divided by 5. This is the number of elements I have in the group, and I get the variance. Here it is. Now standard deviation is the square root of the variance. Here it is. This is the standard deviation. Great, I have the mean, I have the standard deviation. I can standardize each value in the table. So I take the value, reduce the mean from it, and divide it by standard deviation. And for Alice, I take its value, its age, take from it the mean of the group divided by standard deviation, and this is the standardized value for the age of Alice. For Bob, again, do the same, take his age, original age, minus the mean of the group divided by the standard deviation, and this is the standardized age for Bob in this group. And do it for all other elements in the group, and I get the standardized data. This is the original ages, this is the standardized data uh, regarding this group. Of course, each group will have different mean, and each group will have different mean. But in this case, what I did, I converted the data to have a mean of 0. This is a mean of 0, and a standard deviation of 1. And this is what I will do to all other groups in my data. And then all the groups will have mean of 0 and standard deviation of 1. And this will help me compare between the group in a more reasonable way. Thank you very much. This is the way to do standardization for the data preparation. Uh, Important for algorithms like, I don't know, principal component analysis, where we need to evaluate distances and things like this. Then, for clustering, it's important. It has its applications. Thank you very much. If there are any corrections, please correct me. Thanks for GPT, which write it down very neatly. And thanks for Paul, and that's it.